Hello, welcome back to Advanced Artificial Intelligence. This is part two, a practical part of convolutional neural networks, CNN. Um, Part one was theoretical part. I would recommend you to go back to backpropagation, my videos, part one and part two. And then if you have watched those two videos, then you'll be able to understand this one easily. Because this has two passes, forward pass and backward pass. So I am going to explain to you with the example how you implement convolutional neural network. So this is image of tree by tree. Then you've got a filter, 2 by 2, then feature map, 2 by 2. Then you do max pool. You select the best or the highest, and then you flatten, you move from 2 dimension to 1 dimension, and then fully connected. These are the weights, and that's soft max neurons, A and B. You have two neurons. Now, this is the image that you have 10, 10, 10, 0, 10, 10, 0, 0, 0, and the filters 1, 0, 0, 1. 10, 10, 0, 10, 10, 0, 0, 0, 0, 1, 0, 0, 1. So here, if we, and then you have um, uh, W at the output layer, the weight 0.5, and WB 0.1 for neuron B. Now the target for A is 0, target for B is 1. So if we have the image as it was given at the earlier, so just diagram, I think it was 10, 10, 0, 10, 10, 0, and that's 0, 0, 0. And the filter was 1, 0, 0, 1. So this filter would be, we will slide it through the first part of the image. So it means 1 multiplied by 10 and 0 multiplied by 10, 0 multiplied by 10, and 1 multiplied by 10. Let's see, 10 multiplied by 1, correct. 10 multiplied by 0, correct. And 10 multiplied by 0, correct. And 10 multiplied by 1, that's 20. So again, the same filter will be slide through the second part, which is this part, this border. Okay, so it will be 1 multiplied by 10, 0 multiplied by 0, and 0 multiplied by 10, and 0 multiplied by 0. And then this part will be slided through the bottom left of the window. 1 multiplied by 10, 0 multiplied by 10, and 0 multiplied by 0, and 1 multiplied by 0. Likewise, we will slide through this part after that. So this is the first slide, the second slide of the filter on the image, and this is the third one, and this is the fourth one. These are the results. Now we got feature map 20, 10, 10, 10. Next step, we try to do max pooling. In the max pooling, we select the best. So this is the best, the highest. So Z is 20. Next, we are going to multiply Z by two neurons that we have. So that's WA, and that's WB, and that's your Z. So it means 20 multiplied by 0.5 and 20 multiplied by 0.1. That's the connection for each neuron. Now we get 10 by 2. Now we subject that one into softmax. So in the softmax, e to the power 10 over e to the power 10 plus e to the power 2. So that's the result, total sum of two neurons, and then we will find each one of them. So for the A over the total, for the B over the total, We found them. So A is 99.96 and B is 0.04. Now, the first part is finished. This is the image, the filter, feature map, and then max pooling, and the output of the max pooling 20, fully connected, 20 multiplied by 0.5, 20 multiplied by zero point 0.1. So you get these two output, and then softmax was implemented. You'll get A is 99.9 and B is 0.19. Now, and we know that this is certainly class A, but the target is B. Therefore, we need to adjust the weight because the target is label B. Therefore, we have target A is 0, Y B is 1, target B is 1. We predicted 0.9996 for A. We predicted 0.0004 for B. Thus, we have to implement cross-entropy formula, which is loss equals minus Y, the predicted the actual log probability of I. And in this case, because we have only class B is correct, so we put class B probability there, and Y is the target of Y, the B. Therefore, we have L is 7.8, which is very big, uh, which is very wrong, a large loss. We need to do gradient at softmax, gradient at softmax delta L over delta softmax I. It will be prediction minus target. In this case, the prediction is 0.9964 for A. The target is 0. We found it. Prediction for B is 0.0004 minus 1 is the target. We found the both delta, I mean DL over delta softmax for A and for B. For B, delta R over delta S. So these are partial derivative of the output. Now we multiply partial derivative multiplied by the output, which we have Z. Now we find partial derivative over partial derivative of A. So this is the change of loss with regards to weight A, and this is the change of loss with regards to B. So this is the little change that will be added to the old weight of A and B. So this is the change of loss with regards to A, that's amount, and the loss with regards to B, this amount. This is much smaller, you see, for the B, and for A is large. Now, learning rate is 0.1 multiplied by the gradient, and old minus this amount, so you'll get W updated. And we get WB updated through this one likewise. Now we see weight toward wrong class decrease, and weight toward correct class is increased. Okay, is increased. Here we will find the gradient to the pooling max. Gradient to the pooling max would be that's the weight, and that is the gradient. See the gradient. See the gradient for both of them. This is the kind of, let me check. We had, that is the gradient. That is for B and this for A. Now we multiply it by the 0.5 and 0.1, and you see delta over delta Z is 0.39984 at max pooling layer. Max pooling layer. So it means that previously we had 20, 10, 10, 10. Now we have 0.3999, and the gradient for this, the rest, because these are smaller than 20, they will be considered as zero. So 0, 0, 0, and that's the gradient at the pooling max level. Now, because we have input image, so we need to get uh, delta L over delta W at the um, input layer, okay, at the convolutional filter. So input we have 10, 10, 0, 10, 10, 0, 0, 0, 0. Now multiply by the upstream gradient, which was this one. We will update. We will get the change for W1, we will get change for W2, we will get change for W3, we will get change for W4. Now, therefore, if we have these changes, we will update convolution filter for the filter as well now. For the filter is this one, 1, 0, 0, 1. So it'll be 1 minus 0.01 multiplied by the gradient. And you will find W1, W2, W3, W4. Okay, that is how it works. That's how it works. That is how it works. Now, this is the first forward pass and backward pass, and we updated the weight, and we found the Z value is, it was previously 20, now it's reduced to less. Now, if we want to go for second forward pass after learning, we can do that. Again, we have the image and weights are updated now, and weights at the convolution also updated, and weights at the output layer updated. So these are the results updated that we have. So here again, we do a sliding window forward pass for the first slide, but now you see your weights filter are all changed because of the delta that we found. Here as well, for the right top window, we do it, slide filter over the image. This is for bottom left window, and this is for bottom right window. Now the results we have at the max pooling layer, we have 18.4, 9.2, 9.2, 9.6. So max pooling layer means that we take the maximum value to reduce the computation. So this one will be taken, the rest will be not important. And then we flatten to 8.4 as a one-dimension vector instead of matrix. And then multiplied by updated weight for output layer, WA and WB, and this is your Z, which is 18.4. Then you will receive SP and SA, and softmax you find out. You will see the probability of A is now 50.07, and probability for B is now 49.93. So it is, you see now the output has changed, you know. Therefore, You see that was before training. We started first iteration, that's the second one, second forward pass. So you can see that there is some change. Prediction moved dramatically toward the correct class. It was absolutely A to almost undecided between A and B now. So you see one iteration, two iteration, and the network tries to correct itself and improves the output so that it can come closer to the target B. If we are moving forward with the uh, backward pass, again, we'll do the same thing. The backward, let's say we were here. I just want to show you. Here, the results that we found at the output layer, and these are the targets. And here you find the loss, and you see the loss, it was 7. Now it's down, 0.694. See? So the error, it gets down, okay, with the iteration. So if this is iteration, and that's error or loss, so the curve will come down, okay? The curve will come down. Curve will come down. So that's your curve. That is iteration, and this is loss. So you see, that's the difference. Now, this loss will backpropagate through the layers by backward pass. Okay, so we'll find we'll use this formula, and we will find the output for the gradient for the class, and we found the gradient for the class. And then this gradient multiplied by their weights, and then we will get the z this much. Now, here we have chain rule. Delta L over delta W equals delta L over delta soft, and delta soft over delta W. If this goes with this one, you will have this part equals this part. So we need to find this part, and we need to find this one. We multiply them. So this part, it is Z only, because partial differential of S over partial differential in relation to W, that W to the power 1 minus 1, it will be W to the power 0, then W to the power 0, that means only we have Z. So this is gone, only Z, that's 1, that's C. Yeah. So here, for partial differential L over the partial differential W, that is the result. So for W is this one, for B is this one, and you can see that these are the gradients. The gradients will be added to the old weight. You'll find the new weight. And that's what we did. You'll find the new weight for output layer, a new weight for output neuron B and output neuron A. Okay. Now, likewise, we have weight. You see the differences are now getting closer to each other, so kind of optimization. This these deltas for A and B, they will be summed up here. So, and multiplied by their weights, and this one multiplied by its weights. So that's how we can get the result. Now, and we found the results 0.00008. That's very small. And then we have the max. We take 18. You see, earlier was 18, but now we have 0.008, I think, 4 zeros. And the rest the rest will be 0. So 0.0008, and the rest of the vector is 0. The rest of the vector is 0. Okay. Now, likewise, we can backpropagate to the filter level, uh, and at the filter level, we have uh, input at each side of the window. That's how we find it. And that is, we can update it. And these are the weight updates. And you can see that the softmax, how it has been changed, and weight connection, how it has been changed, and also a convolution, how it has been changed. So this is more or less about the convolutional network. We did forward and backward pass, and thank you very much. The most important thing is that we went through step by step, forward pass and backward pass, and they were easy. The rest you can, once the weights are updated, you can do the same, you can apply the same steps uh, over and over in a cycle until you get the right result. Thank you very much and stay tuned.